Hello everyone, in this video let's discuss about a tokenization technique called byte pair encoding. So byte pair encoding is a subword tokenization algorithm, and we use it for tokenizing text corpus in NLP models. Like if you want to feed the text to some kinds of transformer models, we can use this byte pair encoding. So this algorithm was originally developed as a compression technique, not as a tokenization technique, but it was later adopted to be a useful tokenization technique. So we know the tokenization is process of breaking down the text into collection of small meaningful tokens or units. So we use this byte pair encoding for that purpose, tokenization. So generally the tokenization could be done at word level or subword level or character level. So word level would mean in the sense like if we take this text, so this is a word, this is a word, this is a word. So basically at the spaces we can break the text and consider each of it as a token, or we could also tokenize the text at character level, like p is a token, r is a token, like that. And or we could break optimally at some points within the text, not at the character level or at the complete word level, but something intermediate, and that technique is called the subword level tokenization. Byte pair encoding is a subword level tokenization, and byte pair encoding takes advantage of both word level and character level tokenization. Let's understand how. So the issue with word level tokenization is, let's take few tokens like these in English: read, reading, write, writing, walk, walking. So if we see, we need to store each of this token in our vocabulary so that we would be able to split the corpus when in future when we get a inference text, we split the corpus as per this vocabulary. But what if we could do like this, like in our vocabulary we only keep these four tokens like read, write, walk, and there is a special token which is ing. The advantage that we can clearly see is we have reduced directly the token count in our vocabulary. Here we need to save 6 tokens versus here we are only saving 4 tokens. So this outrightly gives us an edge that we don't have to bulk up the vocabulary size during tokenization. So that gives us an advantage with the byte pair encoding. So you could see ing is a part of the word which we are considering it as a token. So that's what when I meant subword tokenization. And at the other end we have character level tokenization where we split each character. So that would drastically reduce the vocabulary size. Like we would hardly have, like in English if we take, there are only 26 letters, right? So there might be some special characters that we might need to include in our vocabulary, but if we consider plain English text corpus, then we would only have just 26 letters in our vocabulary. But the issue with that is each token would lose any semantic meaning, and the models find it very hard to learn the inherent semantic or like language understanding from the corpus, because each token doesn't have any meaning or significance. So that's how byte pair encoding is like the middle ground and better than the word level and character level tokenizations. So what is the basic idea of byte pair encoding? So the basic idea is we'll iteratively merge the most frequent pair of co-occurring bytes or subwords. So initially in the training phase in byte pair encoding, to learn the tokens, let's assume like byte is nothing but a single character or like some subword that would come up like later in the further steps during the tokenization. But the idea is like, let's call these bytes or subwords as units. So we iteratively merge most frequent pair of consecutive units in a text until we reach a vocabulary size. So initially we start with very small vocabulary size and keep incrementing the vocabulary size based on some procedure which we will see. That's the byte pair encoding algorithm, and we will increase the vocabulary size until we hit a fixed size of vocabulary. So that is a parameter that we decide before starting the byte pair encoding. And while increasing the vocabulary size, we also learn the merge rules. So what is a merge rule? We'll see. So the resulting set of vocabulary or tokens along with the merge rules would be used to tokenize any new text. So it became popular and it is used in most transformer models nowadays as a tokenization technique, but it was used in GPT models first. So let's understand the byte pair encoding algorithm. So first what we need to do is in our corpus we need to first normalize the text. That means bring the text to a single case. Then we would be doing something called pre-tokenization, that is identifying the unique words in the corpus. So it could be based on the space. As a delimiter, we could split the text and create the unique set of words in the corpus. So basically that process is called pre-tokenization, and we also get the count of unique words. So this count is useful when we implement the algorithm, that when counting the co-occurrences, if we keep track of the count of the words at the beginning itself, it would be easy to keep track of or count the number of co-occurrences instead of doing it again and again from the beginning. Then we need to create a base vocabulary. Base vocabulary is nothing but all the unique characters in our text corpus would be our starting base vocabulary. Then we need to fix up to what size we need to grow the vocabulary, and we will iteratively grow till that point and then stop. So once we have our words ready and the base vocabulary ready, then we will pick consecutive pair of co-occurring characters or like co-occurring tokens in our base vocabulary and identify which pair has the highest co-occurring count. So we would see all this with an example. So I'm just first listing the steps in the algorithm. So we would identify that highest co-occurring pair, and then we would consider that as a merge rule. So basically if two letters, let's say C and A, are occurring most frequently in our corpus, we would combine them into a single token CA, and we would treat that combination as a merge rule. And basically as a step 4, we would merge the most frequent consecutive pair as a single token and add it to the vocabulary, and also save it as a merging rule. So this process is called learning the merging rules. So this merging rule is later used when we are tokenizing the new corpus or new words. So we'll repeat these steps like identifying the most co-occurring pair of tokens in our current vocabulary, merging it, then adding that merged token to our vocabulary, and also repeating this process until we reach the desired vocabulary size. So we have seen how the byte pair encoding algorithm works. So in the next video, let us actually see the application of algorithm with an example. Thank you.